Okay, hello everyone, welcome back. I hope you have a nice Thanksgiving break. This is the last week for our class, and we plan to finish the crash recovery this section in this week, and we also plan to take one class to discuss about the final exam for you. And we have 3 classes in this week, so we plan to take 2 days in this week to finish the crash recovery and then take 1 day on the final review for you. For the crash recovery, we will talk about these 2 techniques we can use for recover the systems from crashes. One is called undo, another one is called redo. We will discuss them in detail in this week. And we also have a reminder for you. By this Friday, we have a deadline for both homework 4 as well as stage 4 of the project. So remember to submit both the solutions answers of homework 4 as well as the report of the project to the camera system before deadline. And for the project, you also need to do the demo according to the TA's instructions. Please upload the demo videos to YouTube and also post the links in the report as well. So we have generally finished all the sections in this week already, and in the next week we plan to have the final exams. So for the contents to be covered in the final, we will cover all the topics we have discussed in this course. I mean, all the topics from the introduction to the ER model, relational algebra, relational design, SQL basics, modifications, constraints, indexing, as well as crash recovery. All the materials we have been discussed before will all be covered in the final exams, so please take some time to prepare for the final as early as possible. Final will take most of the portions of your final grade. It takes about more than 35% of your final grade, so please take some time to prepare for this. Okay, so let's come to the crash recovery section. We will talk about the undo first and then talk about the redo. So in the last week, we have discussed about the basic information for the crash recovery, right? We have talked about the transactions as well as the basic properties of transactions. If you still remember, we mentioned the ACID, these 4 properties of a transaction, right? We also mentioned that for a database system, we should maintain a consistent state during the running time. If before we run a transaction, the system is in a consistent state, then after we finish the transaction, the system should still be in a consistent state as well. So the consistency is very important for database systems. We also mentioned for any transactions running in the system, they can be either be aborted or can be committed. So aborting means we didn't run the transaction successfully and we make some mistakes. If a transaction runs successfully, then all its action must be committed, right? And we have all the effects made by the transaction in the system. So either abort or commit, we must end the transaction with one of these 2 choices, right? So let's talk about the abort of the transaction first, which is called rollback as well, right? If a transaction runs and we make some mistakes, then we have to abort a transaction and roll back. So as shown in this page, if a transaction like TI is one transaction, I is the index, is aborted, then all its action must have to be undone or undo. In other words, we have to eliminate the effects made by the action in this transaction. Here we also need to be careful. Note that if another transaction TJ, J is a different transaction, reads an object not returned by TI. In other words, this TJ reads some object which is returned by the TI, and TJ depends on the TI actually. Then TJ must be aborted as well. In other words, the data we read based on TI is not reliable because the TI is aborted, then the TJ must be aborted as well because it reads some unreliable input for the object, right? So this is called cascading abort, and this can be common in the database systems if we don't have any protections for the reads or data reads among different transactions. And most systems will avoid such cascading aborts because if in a system we have so many different transactions running at the same time, and these cascading aborts can be very costly because so many transactions must be aborted if one is abort happens. And to avoid such cascading aborts, we can release transaction logs. In other words, if we read some object, we can unlock it before some other transaction finishes. We can release some locks only at a commit time. So for example, if Ti writes on some object and Tj can read this object only after Ti commits. So during the running time of Ti, we can lock this object, and after Ti finishes, then we can unlock this object and Tj can read this object. In this way, we can avoid this cascading abort because Ti will read this reliable object after Ti finishes, right? So in this way, Tj can be running in a successful way, which is independent on the Ti anymore via these locks. And in order to undo these actions of an aborted transaction, the DBMS can maintain a log in which every write is recorded. This log is very important because all the crash recovery techniques we will discuss in this lecture, they are based on logs in the database system. If you still remember the architecture we showed in the introduction, so log is an important part or component of a DBMS. It records all the actions we make in the system, and if the system crashes, we have to use the log to help us recover the system to a consistent state before the crashes. And all the active transactions at the time of the crashes are aborted when the system comes back up. In other words, if we run a system and during some time and the system crashes, and all these aborted transactions must be rolled back before the crashes or before it starts, after the system comes back. In this way, we can roll back the system to the previous state, which is consistent before the crashes. Even though we have some losses because these transactions, they are rolled back, they are aborted. However, we can still do them after the system comes back. Okay, so this is about aborting a transaction. You see, this abort heavily relies on the log in the DBMS.